All right, good morning. Today we're going to be talking in Math 101 about section 2.5. So we're going to call this the 2.5 online class. And in section 2.5, we are going to be solving equations just like in section 2.4. But the variable is going to be on both sides of the equations here. Solving equations with variable on both sides. I'll be a little informal here. Okay. All right, let's jump right in and do an example. This is example 1 on page 130 in our text. Please look along in your text as we go along here. You'll see these look very much like the equations we solved in section 2.4. And we're going to be doing basically the same things. We're going to be doing algebra things to both sides of the equation to isolate the variable, here it's x, on one side of the equation and get a number on the other side, hence getting a solution that x equals some value. All right, so here I'm going to subtract 2x from both sides. We've got variables on both sides of the equation, as you can see. All right, if I subtract 2x from both sides, the x's are going to cancel out on the right. Well, if you're going to do that, you would probably then subtract 6 from both sides, because then you'll get a minus 6's, or the plus and minus 6 cancel on the left. I'll end up with 4x minus 2x is 2x on the left, equals 4 minus 6 is minus 2 on the right. I'll divide both sides by positive 2. The 2's cancel out on the left. And of course, minus 2 over 2 reduces to minus 1. So I've got a final answer of x equals negative 1. And again, the book makes a big deal about checking your answer. I'm not going to make such a big deal on checking your answer. Certainly at some times it's appropriate. I'll let you decide when and when it is not appropriate to check your answer, especially on test day with limited time. All right, so let's try another more difficult example. I'm sure you've all done this before in your math careers. Example 2 on page 131. 2x minus 3 minus 5x on the left equals 13 plus 4x minus 2 on the right. All right, as you can see, we've got variables on both sides of the equation. And what I'm going to do is simplify on each side first. There are like terms that I can combine on both the left-hand side and the right-hand side. So let me do that first. On the left, 2x minus 5x is minus 3x, and don't forget about the minus 3 being subtracted there. And similarly on the right, 13 plus negative 2 is going to be 11. All right, so I can crunch those numbers together and get 11 plus 4x on the right. All right, so again, the goal here is to isolate the variable on one side of the equation, but do you want to isolate it on the left-hand side or the right-hand side? Well, I suppose you should be able to handle it either way. I think what I'm going to do here is add 3x to both sides. I think some students and some teachers like to have a positive coefficient on the x variable if possible. All right, so if I add 3x to both sides, the plus and minus 3x are going to cancel out, and I'll have a x variable on the right-hand side with a positive coefficient. All right, if you're going to do that, I would probably then subtract 11 from both sides, canceling out the positive 11 on the right, and getting a sum of minus 3 minus 11 is minus 14 on the left, equals 4x plus 3x is 7x on the right. All right, so I've isolated the variable on the right-hand side here. So now I'm going to divide both sides by 7. The 7's will cancel out on the right. And of course, minus 14 divided by 7 is minus 2. So I'll get the final solution, x equals minus 2. Okay. Let's look at another example in the text. Example 3. I'm going to do about 9 or 10 examples in today's class. From this section, example 3, page 132. All right, we've got something a little more complicated here, not too terribly bad, I think. You've got a symbol of grouping, or parentheses, involved, and clearly to join up these p variables, I've got to bust this p out from that parentheses. So let me go ahead and apply my distributive law here, perform the indicated multiplication here, and I can drop the parentheses. 2 times p is 2p, plus 2 times 3 is 6, equals minus 3p plus 10 on the right. All right, do you want to isolate on the right or the left? I suppose most students here would prefer to add 3p to both sides. That'll cancel out the minus 3p on the right. And then if we were going to do that, you would probably subtract 6 from both sides, because then you'll cancel out the positive 6 on the left. All right, so performing the indicated addition, I will get 5p on the left equals 10 minus 6 is 4 on the right. Then dividing both sides by positive 5, I get a cancellation of the 5s on the left. I'm left with 1p, or p, equals 4/5. Final answer. All right. I remember, no decimals, please, on test day. No decimals and no mixed numbers. We already talked about that in earlier lectures. Okay. Let's try example 4 on page 132. All right. 2 times x minus 5 plus 3 equals 3x plus 9. Now notice this 3 here is not included, of course, in the parentheses here. So what I'm going to do is apply my distributive law and perform this indicated operation. Hang on a minute, I messed up. Let me make that clear. 2 times x minus 5, all right? So there's a indicated multiplication here, and I will perform my distributive law in order to drop those parentheses so that then I can free the variable terms up to join together. 2x, 2 times x is 2x, minus 2 times 5 is 10. So I've got 2x minus 10. Don't forget about plus 3 on the left. 3x plus 9 still on the right. All right, I can crunch these numbers together, of course. 2x, well, negative 10 plus 3 is negative 7, of course. And I've done as much arithmetic and simplifying as I can on each side. Now I'm going to combine like terms across the sides. I would probably subtract 2x from both sides. That'll give me an isolated x term on the right with a positive coefficient. If you're going to do that, I would probably subtract then 9 from both sides. All right, so these terms cancel out. These terms cancel out. Minus 7 minus 9 is minus 16 on the left. And, of course, on the right, 3x minus 2x is plus x. Plus 1x or just plus x, just x, I guess. All right, so x equals negative 16 as a final answer. All right, let me get a fresh screen. All right, let's look at example 5. This is on page 133. in our text. And again, please look along in the text as we go along. Sometimes I do different things than the author does. All right, so 7 minus 2x plus 5x equals minus 2 times minus 3x plus 4. All right, it's nastier still. What can I do here? Well, I can combine these terms. These are like terms, the minus 2x and the plus 5x. And of course, I can perform the indicated multiplication here, right, to drop these parentheses and then join up like terms across sides. All right, minus 2x plus 5x on the right is equivalent to 7 plus 3x equals, on the right now, I'm going to apply my distributive law. Minus 2 times minus 3x is plus 6x. Remember, negative times negative is positive. And of course, a minus 2 times a positive 4 is minus 8. All right, do you want to isolate on the left or on the right? I think our textbook isolates on the right here, so let me subtract 3x from both sides. That'll cancel out the x term on the left, and then I will add 8 to both sides, and it's canceling out this constant on the right. All right, on the right, 6x minus 3x is 3x, positive 3x, and of course 7 plus 8 is 15. So 15 equals 3x. If I divide both sides by positive 3, I'll get a 5 on the left and just a 1x or an x on the right. So x equals positive 5. All right, let's try some equations with fractions in them. Don't panic. And certainly don't run to the calculator. Equations with fractions, and of course, within the title of this chapter, it implies you're going to have variables on both sides of the equality also. Let's look at example 7. Now, the book does it one way. I'm going to do it a different way. Example 7 on page 134. So please take a moment to get your books out to look along. Let me write down the problem first. 1/2 a equals 3/4 times a plus 1/5. So certainly we've got fractions on equation with fractions in it, and of course variables on both sides of the equation. Let me clean this up a little bit. All right, so 1/2 a equals 3/4 a plus 1/5. All right, now the book, the text isolates the variable on the right. We will isolate on the left here, just to convince you that you can do it both ways. You should be able to handle it both ways, right? So I want to end up with an a term on the left-hand side of the equation. All right, first thing I'm going to do here is multiply through by the LCD. We've got 3 denominators here, 2, 4, and 5, and the least common multiple, the least common denominator of all these denominators is, of course, 20. All right, so if let me rewrite the equation here. If I take a little time and show some good housekeeping and multiply both sides by the LCD, all these fractions are going to go away. Let me show you. We'll have an equivalent equation, and the LCD is 20. I need a little room here. We'll have an equivalent equation with no fractions in it. All right, now on the right-hand side, you're multiplying a sum. So you'll have to apply your distributive law, hence I'm wrapping these two terms in parentheses and indicating a multiplication of both terms by 20. On the left-hand side, well, we've only got one term, a sum of one term. All right, so I can just go ahead and multiply 20 times 1/2 times a. Well, 20 times 1/2 is 10, and 10 times a is 10a. On the right-hand side, 20 times 3/4 a. Well, the 4 cross-cancels into 25 times, and 5 times 3a is 15a. Let me do that again. 4 cross-cancels into 25 times, and 5 times 3a is 15a, plus 1/5 times 20, well, of course, 5 cross-cancels into 24 times, and 4 times 1 is 4. All right, so now it's a breeze. See how easy it is if you take a little time and clear away those fractions properly? It's a breeze, right? All right, we're going to isolate on the left-hand side here, right? So I'm going to want a residue of the variable to be on the left. So I'm going to subtract 15a from both sides. I'm having trouble. Hang on a minute. Minus 15a from both sides. And we're going to isolate on the left here. All right, so that'll give me, I'll go ahead and add or subtract as indicated. I get a minus 5a then equals, these terms cancel out, of course. Minus 5a equals 4. Now I'll divide both sides by negative 5. Of course, I get cancellation on the left. 1 times a, or just a on the left, equals 4 over minus 5. And again, you can absorb that negative sign in either numerator or denominator. And I think most students in the textbook would have that as a final answer. Okay. Let's see, 2 more and we'll call it a day. This is example 8 in our textbook on page 134. X over 4 plus 3 equals 2 times x minus 2. All right, so here we've kind of got it all. Variables on both sides of the equation. We've got fractions and all kinds of things. Or groups of, or symbols of grouping, parentheses as well. All right, what shall we do here first? Well, I suppose I would multiply through by the LCD first. I only see one fraction. All right, so the LCD is just going to be that denominator 4. So if I play my cards right, show some good housekeeping. All right, I'm going to multiply the right-hand side by 4 also. Now notice, because 2 times x minus 2 appears already on the right-hand side, I can just throw in another factor, multiply 4 times 2 first here, and then multiply through the parentheses by 8. All right, so let me go and simplify the left-hand side first. 4 times x over 4, you've got to apply your distributive law. I'll get x, 1x, or just x. Then 4 times positive 3 is 12, so I'll get x plus 12 on the left. On the right, 4 times 2 is 8. So I've got 8 times x minus 2. I'll go ahead and perform that multiplication on the right. Free up those parentheses. I'll get 8x minus 16 on the right. All right, you want to isolate on the right or on the left? I suppose it's a matter of taste. I think our author subtracts x from both sides, hence giving an x residue on the right. If we do that, we would probably add 16 to both sides. All right, the x's cancel out on the left. This positive and negative 16 cancel out on the right. I'll get 7x on the right equals 28 on the left. All right, so dividing both sides then by 7. I'll isolate x on the right-hand side here. 28 divides evenly by 7, so I get 28 sevenths is 4, and x equals 4 as a final answer. All right, let me get a fresh screen here, one more, and we'll call it a day. All right, this example, it's kind of nasty, and it does represent the upper limit of difficulty in this section. So beware, it's a little tougher. 1/2 times 2x plus 3, so it's got fractions in it. And 2/3 times x minus 6, it's got variables on both sides of the equation. And of course, parentheses or symbols of grouping also involved. All right, what are we going to do here first? I suppose I see a 2x here, and 1/2 times 2x is going to give me an x with no fractions involved here. And I can similarly multiply this parentheses through by 2/3. I'm going to do that first. I'm going to multiply this first parentheses by 1/2, and then multiply this second parentheses on the right through by 2/3, and then see what we've got left. 1/2 times 2x is going to be 1x, or just x. All right, so that takes care of those two products. Recall you've got to use your distributive law here, and 1/2 times 3 is going to be 3/2. So on the left-hand side, we'll have x plus 3/2. On the right, similarly, 2/3 times x is 2/3 x, minus 2/3 times 6. Well, of course, the 3 will cross-cancel into the 6 twice, and 2 times 2 is going to be 4. So I get 2/3 x minus 4 with this product. And don't forget you've already got a 4 term outside here. All right, of course, I can see that minus 4 plus 4 is going to lead to 0 in a more simplified expression. So let me go ahead and do that. And I'll end up with the statement x plus 3/2 equals 2/3 x. All right, now I'm going to clear away the fractions. I see the LCD is going to be 6. The least common multiple of 3 and 2 is, of course, 6. So I'm going to multiply both sides, all terms, by positive 6. On the left, you've got a sum, so you'll have to apply your distributive law. 6 times x is 6x, plus 6 times 3/2. 2 cross cancels into 6 3 times, and 3 times 3 is 9. All right, so the left-hand side reduces to 6x plus 9. On the right, it's not a sum, it's a product here, so I can multiply 6 times 2/3 and then take that result and multiply it by x. 3 cross cancels into 6 twice, and 2 times 2 is 4. And 4 times x is 4x. So the right-hand side simplifies to 4x. All right, now it's a breeze. I'll just subtract 4x from both sides. I would then probably subtract 9 from both sides. The plus and minus 4x cancel on the left. The plus and minus 9 cancel on the other left. So 6x minus 4x is 2x, equals minus 9. Doesn't combine with anything on the right, but I still have to subtract 9 to keep balance. I will then divide both sides by positive 2. I get x equals minus 9/2 as a solution. Again, no mixed numbers, please. No decimals. No mixed numbers in your final answers at this stage of the game, okay? All right, this concludes section 2.5, solving equations with variables on both sides of the equation.